numbers are equal to each other. Oh, if everyone's done quizzing at the table, let's take those barricades down. But let's not fold them up. Let's just lay them out completely flat. And I know they're huge and this is awkward, but let's just bring them over and lay them in a nice pile over here. But when we fold them up, that's when they seem to fall apart. So I retaped everything, and I'd like to not have it. So only do that if everyone's done quizzing. We don't want to have a bunch of quizzing going on. There's only one person quizzing. Okay, I'm really sorry about that confusion. Hopefully in January we won't have this anymore, but for now, that's what we have. Okay, if two complex numbers are equal, that means the parts without the i's are equal, and the parts with the i's are equal. Does that kind of make sense to you? Think about graphing them yesterday. Remember, this means go over 2 and up 3. If that's going to be the same as this one, then isn't it also going to have to go over 2 and up 3? So clearly, x is 2 and y is 3 in that problem. Now, 24 is exactly, as Jessica said, the same concept, but a little bit tougher. Everything, make sure I copied that right. Everything, just like in this problem, everything with an I is equal and everything without an I is equal. So let's look at this thing. What does not have an I on this side? X. So that must equal everything on that side that doesn't have an I. So what doesn't have an I over here? Well, 3 plus 4. So x is 7. These things are equal. So what does have an I on this side? 6. And what does have an I over here? Negative 1 minus 2y. So 7 equals negative 2y and y equals negative 7/2. Got it, Jessica?
Yeah.
Okay.
It doesn't have anything to do with the I, really. It's just the I tells you.
It's just that separates the like terms. So the like terms on each side are equal. Okay. 26 says 1 minus I cubed. Well, later on we're going to learn a little faster way, or maybe you did it last year to do this, but for now we're just going to FOIL, and it means we're going to FOIL, 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 right? 3 of them. So we'll multiply these 2 together first. Remember, when you multiply, you can only do 2 at a time. So I'll multiply those 2 together, and that will give me 1 minus I plus I squared. Okay, so this makes negative 2I. What's I squared? Negative 1. So I have a 1 and I have a negative 1. Those just cancel. So that just FOILs to negative 2I. That's not the answer though. I still have to multiply it by the other one. So that now isn't even a FOIL, it's just a plain distribute. So that'll be negative 2I. What's that going to be? Plus 2I squared. And what's plus 2I squared? Negative 2 minus my 2I. That is what you get. You FOIL it all out. Does that make sense? Okay, who else had a question about one of the homework problems? Yes, ma'am.
29.
29. Find the product of the complex number and its conjugate. What's the conjugate of 2 minus 3i? 2 plus 3i. So we're just going to FOIL. It says find the product. That means multiply the number and its conjugate. So we're just going to FOIL. And these cancel. That's what happens when we multiply conjugates. And what's a negative 9i squared?
9.
Plus 4? So the answer is just 13. Anybody else? 33, right, expression 1 over 2 plus I. We talked about this yesterday, Anna. How do we divide complex numbers?
Conjugate.
Yep, we're going to multiply top and bottom by the conjugate. You're not sure
Oh.
this morning, are you?
No, I know how to do that.
You
You're
do?
like, yeah,
So we're going to multiply top and bottom by 2 minus I.
yeah,
So the numerator will be 2 minus I.
yeah, I like.
And then I'll FOIL the bottom, so I get 4. These are going to cancel, that's why I do it minus I squared. So I get 2 minus I over 5.
Because it's minus I, so then. it's
Minus I squared would be negative 1, which is positive 1.
Okay.
And then what they mean by standard form is A plus BI. So I would split this up. Now, for me personally, this is fine, but the directions said standard form. So that would be 2/5 minus 1/5 I. Just kind of uncommon denominator then.
Okay, but if you're on the quiz test, we do that one.
Yeah.
Okay.
Okay? Now, today what we're going to do is solve some inequalities. Okay? Now, this is not hard. But I need you to really pay attention because, and be disciplined, because it's not hard at all, but we fall prey to these temptations sometimes, and we just can't do that. So let me show you what I mean. Let's say we have an inequality x squared minus 4x minus 5 greater than or equal to 0. This is called a quadratic inequality. Quadratic, right? Inequality. Now take a wild guess how we might start. Just a wild guess.
Factor complete square.
Okay, I've heard quadratic formula, I've heard factoring, and I heard completing the square. Any of those will work. But I'm going to promise you that the ones I give you will factor. Though it's easier if you factor them, and so I'm not going to get wild and wacky. I'm going to give you problems that factor. If you choose to do it a different way, then adapt your method to what we're going to do here with the factors, because it really is easier to factor these. Okay? So somehow you all knew what to do. You said, I need the roots. I need to solve it. Right? You solved it different ways, but you need to solve it. Yes. So I'm going to factor this. Here I go. Now, this is where you must exercise self-discipline. If this were an equals sign, you would say this equals 0 or this equals 0, right? In an inequality, that does not work. So fight the temptation to say, this is greater than 0, this is greater than 0. It doesn't work. You will not get the right answer. Instead, what you do is you draw a number line. And on the number line, you plot the zeros. So those of you that did this a different way, quadratic formula, completing the square, you're going to get the same zeros as I did. You're going to get negative 1 and 5, and you're going to plot them on the number line with solid dots. Now, do the solid dots make sense to you? Now, we are going to check each region of this number line. You have, by putting 2 dots on the number line, you've split it up into 3 pieces, agreed? We want to see which of the sections of the number line that you have will work in terms of the equation. So here's what I mean. I'm going to pick a number over here. Any number I want that's on this end of the number line. So what would be a choice? Negative 2. I'm going to put negative 2 back into my equation. Now, you can put it in up here, or you can put it here. I prefer to put it into the factors, because all I want to know is, does the answer turn out to be bigger than 0? Bigger than 0 means positive, right? So if I put in a negative 2, this factor would be negative, and this factor would be negative. Do you see what I'm saying? I don't even need to calculate it out. I don't even care what the numbers are. I'm just interested in ending up positive. These two are getting times by each other. So if I take this negative factor times this negative factor, will I end up positive? So this section of the number line works. I tried -2, it gave me a positive result, so these numbers are answers. Okay, Deanna, I see confusion. Let's pick a number in here. What would be a number in between -1 and 5? Any number? 1. So put 1 into this parentheses. Would it be positive or negative if you put 1 in there? Negative. Put 1 in here. Positive or negative? Positive. Now what happens when you multiply this negative parentheses times this positive parentheses? It's negative. It is not positive. So therefore, this section of the number line, not part of the answer. Let's move over here. What's a number out here? Yeoman, what's a number out here?
6.
6. What happens when I put 6 into both of these parentheses? It would make this one positive, 6 would make this positive, and 6 would make this positive. So when I times them together, that is what I wanted, right? I wanted a positive result. So my answer is all the numbers less than or equal to -1 or greater than or equal to 5. Now, I totally hate gimmicky little things, but it is true that if the problem is a normal problem, that is, there's no squares or cubes or anything odd floating around in it, it's just a normal problem, you will see this alternating pattern here. See how this section worked? This one didn't, this one did. So had I been doing the problem and the first section didn't work, then this one would and this one wouldn't. That holds true all the time as long as there's nothing funky going on in the problem. As long as it's a normal standard problem, you can kind of do that alternating thing to save time if you want to. Okay, ready to try another one?
So you don't need to do like when you like apply the rules of like a regular non-inequality, and there's just equal
I
signs
don't know
to
what you're
those.
talking about.
Like on this one, like if you would have done it like a regular one, and you would just do x plus 1 minus 1 to like the other side, it wouldn't work. So it wouldn't be x is greater than or equal to -1. That does those rules don't
No,
apply.
that's what I said. That's
Yeah,
the
I just-
temptation.
Yeah.
Yes, and we don't ever do that. In inequality, we draw a number line every time. Every time.
And so you want us to like plug in a number to determine whether it's greater.
Yep.
Okay.
Yep, that's the only way to do it. That's how you do it. Now, guess what the temptation's gonna be here on this problem? To take the square root of both sides. Guess what? You can't. It's not an equation. How do we solve inequalities? We factor them and plot them on a number line. Be strong. Fight the temptation. We get this set equal to 0. We factor it, and how does this one factor? We draw our number line. Where will the dots be? -3 and 3. Will they be open or closed? Open. Nothing odd about this problem. So pick a number somewhere. I don't care. Pick any number on the number line. What number you want to pick? 2? Where's 2? 2's in here? Okay, so let's try it. Let's put 2 in. 2 gives me a negative here and a positive here. Remember, this is a multiplication problem. Does a negative times a positive give me what I want? Yes, because what I want is negative. So this section of the number line worked. We picked 2. Now, if that section works, what can you tell me about this section? It won't, and neither will this one. So the answer to the question is all the x's between -3 and 3. Now, if you are more comfortable checking every region, that's absolutely fine. That's absolutely magnificent. So if you want to check every section, you're just more comfortable with that, that's fine. One more. What do you do? How does that one factor? Number line dots are where? Be careful, they're at -3 and -1. And when you put them on the number line, make sure they're in the right order. Open or closed?
Closed, open.
One or the other, right? They're open this time?
Yeah.
Now, what do you want to pick, where do you want to pick a number here?
I have a question. When you plug in the number, does the number have to be like for, I don't know why, but like when I did it, so you have to do the same number for both x's, like the x's, okay. So if you did like negative, if you pick -4 to plug
Put
in.
it in both, so that would make this one negative and this one negative. If you put in -4, it would make this parentheses negative and this parentheses negative.
Okay.
So when I multiply a negative times a negative, do I get what I want?
No. Yes. Oh, yeah, you do.
Isn't this positive?
Yeah.
So then negative times a negative gives me a positive. So this section, the number line works, because you picked -4, which is in this section of the number line. It worked, so this is an answer. How about this? And this. So now I'm going to do one of the odd ones to show you what I mean by an odd problem. My answer ends up being everything less than -3 or greater than -1. Easy enough? Now, what if we had a problem like this? Now, first of all, you see what I mean by strange? They got a squared factor in there. That's going to change everything. Well, not everything, but it means I have to be very careful. So I'm going to have a dot at -1 and a dot at 4. Would everybody agree those are the two numbers that give me 0? All right, so let's pick a number out. Oh, by the way, what does greater than or equal to 0 mean? I'm looking for positive. Okay, so we'll pick something out here. Notice I put these on in order. They have to be in order. So how about -2? What would -2 do here? Negative. What would -2 do here? Be careful. Positive, right? Because you're squaring it. Does that work? No, I'm not going to color that. All right, let's pick a number in here. Maybe 0. Negative. Brandon, Ely, get your head up. Is O'Malley even awake here?
Yeah.
Okay. So I'm putting in 0, so I got a negative here. What happens here when I put in 0?
Positive.
Oh my goodness, does that work?
No.
Okay, let's put in 5. 5 makes this positive, positive, so that works, right? So what's the answer to the question? Everything that's colored. So either x equals -1 or x is greater than or equal to 4. If this had not been there, if they or equal to hadn't been there, how would that change my answer?
It would just be x is greater than or equal.
It would just be x is greater than 4, because that would have been an open dot, which means not included, and so the answer would have just been x is greater than 4. Okay? 2 more kinds of inequalities. One, these are your polynomial inequalities. Most of them were quadratic, but I threw this cube in there a minute ago. How about an absolute value inequality? Now I'm going to stretch your brain here for a minute and ask you to think like a calculus student. A couple days ago, a few days ago, we talked about absolute value inequalities. You had to write some. I don't think you solved any, but you had to write some. And we said that when you subtract two numbers and take the absolute value, what are you really thinking about? What does that translate into?
How far it is away from 0.
How far apart these two numbers are, right? The distance between them?
Yeah.
So this inequality literally says the distance between x and 2 is less than 5. So the distance between these two numbers has to be less than 5. Now I'm going to redraw that for a second. I don't know where x is, but there's 2. The distance between some number and 2 is less than 5. So what would be the furthest out that number could be if its distance has to be less than 5? 7. And what if we went this way? Because we really don't know which way it is. What if we went back this way? -3? Now if the distance has to be less than 5, would you think that we're in between -3 and 7, or are we pushing out from -3 and 7? In between. Why?
Because
The distance is less than. So the answer to the question is all of the numbers between -3 and 7. Let's try another one. You're thinking like a calculus student now. This is how calculus students think. Now what does this say? I see an absolute value of a difference. So I immediately think the distance between x and 4 is bigger than 5. So here's 4. Where is x going to be so that the distance is more than 5? Well, the upper bound would be 9.
Yeah.
And that's closed in this time. And the lower one would be -1. That's closed in, right? Now, you're either going to want the numbers in between or you're going to push out. In this case, we want the distance to be
pushed out.
more than 5, so we want to be farther beyond these points. So our answer is less than or equal to -1, greater than or equal to 9. What if I do this? What's different about that? It's a plus. Now, how does that change things, or how do I deal with that?
No, it's just 1. Right? With 1 value because it goes to.
If I'm thinking about this as a distance, it has to be a difference. So instead of saying x plus 3, I might think about it as x minus -3.
Can't you say
Put -3 on the number line. We finish this tomorrow. Have a good evening. Have a great night.
Alright, so
Remember,
I'm gonna make a bunch of flowers Oliver or I don't even know an option. Oliver's kind of nice. I know.
have a great day.
Something cute. Those are so fun. I did a rhino and kangaroo. Does anybody see?
Have a great day, girls and boys.
Yeah, why?
I didn't really.
Do you get her today? Why?
Oh, yeah, I need to fix that.
But it was like we should have.
Show me your quiz. Who knows what in the heck I did. 25.5, what do I have in there?
I think it's 22.
Launch, okay.
Start running.
First period. It's spinning. Okay, random, there it is. And it's supposed to be a 25.5. Got it, fixed, all done.
Oh,
Good job. Sorry about that.
We just sat there in the library. On touchscreen computer. What? It was tight.
Oh, that's
Yeah.
Well, it's not a computer.
It's a computer.
What's going on?
talking about IPY computers or touchscreen.
Oh, is that good? I don't know, what's different about touchscreen? I mean, I know, but I mean, does it make it faster or easier?
Just makes it easier, maybe. Just makes it cooler.
I don't know, like typing?
I like having the physical keyboard.
Yeah, I don't know how you would
There's like that
type.
one, I don't remember what it's called, it's like a
I
computer
type faster
has a
than I-
keyboard where you can like flip it around.
Oh, that thing? Oh, Lenovo?
Yeah, the new
Yeah,
one.
my dad has all those. I don't like it at all. It's so slow.
And then you can just add battery.
No, I mean like the program's loading on it.
I was just kidding. I wanted to see. I don't understand why I love to see all.
Dude, I'm Carolina and Denver.
I had the Browns.
I have they're actually going to be really good.
I have the Patriots.
Did you see them last night?
Patriots.
Washington first and goal on the 1 yard line, and they held them for 4 plays. They went for a 4th down. Their defense appliance.
Like their backfield though.
I saw you say, I did.
Their backfield.
I just know your face. Like, oh my god, I'm so offended. Guess what Kendall likes? Exactly. Guess what Kendall likes? Is it yours kind of looks like? I don't have a graph. You don't have to do the graph. But yeah, no, it's right. That wasn't part of it. You said like this trace. But anyway, I was like, they were talking about LP. They were talking about LP, and she goes, like, saying all these LP. They were in her class, and she walked in, she's like, I'm not in this class. Like, who said that? I don't think she knew I was in it. Like, LP. Everybody. She reminds me of, like, dude, every single person. Are you kidding me? I am like, I'm so. People would think I can do things like I did. So today is ridiculous.
Softball classes are real today.
No, it's one of those regular. So my mom got on me about not going to the old folks home, so I have to make sure I find games. I know. I'll go with you guys for sure. I know, but I didn't. Are you going?
No, not everybody has one. You have,
Are you?
okay, everybody on one side of the table has one, and only the next
She
person
just
on
asked
the
me
other
to.
side.
Yeah, so you're confused.
I think it's everybody on one side has one.
Lovely. Who is it? When is that? 30th.
Who are you on?
Didn't bring it. Oh, you're paying for it. I like your shoes.
This is an intensive one.
My brother's here. I guess they really felt like those ones are good. And you like can't look.
I feel like you do this stuff without a camera.
It was like, that's like a dog. Can you imagine imagine walking into a class.
I'm just calculator.
I'm just like
I could just
Share the calculator. How do you work it? You guys don't know how to work it?
I just woke up. I just woke up.
You type y, and then plug in the formula, and then
I need you to come with me.
I'm sorry.
and then you plug in the formula, and then you pick what days you get for Q-Honor. You haven't given me my hours yet?
I know.
You have to work a cash register? Probably.
That way, I'm not thinking to like let it sit. After class, that's all I ate.
And I'm not even gonna talk about it. Michael did it yesterday. Everybody always does it. Michael did it yesterday, but purposely smashed my whole lunch like that. Caitlin today.
Maybe you can stay there, you can stay there. You two, you need to find a place to sit.
Okay, I'll sit.
You can sit there, you can sit back on the comfy chair spot. Okay.
Suzanne, I don't know about it.
Listen, you do not need a calculator, but if it's easier for you to use a calculator, you may use one. But you do not need it. There's absolutely no reason you need one. Okay? So we're all spread out. We got our little wings set up, so we're hiding. You don't want anybody cheating off you.
Just what we've done.
Ron? Yeah. Okay.
I'm going.
Okay. Where is Tyler? Here's an old quiz that I returned.
My hands smell like voids.
All right, this is only one side of the paper. The problems are exactly like the three we did yesterday in class. No notes. If you want to write on a notebook, that's fine, because the desk is so rough. It annoys me to write on it, but maybe it doesn't bother you.
So we do graph?
Ms. Ford?
You are free to write on a folder or a piece of paper if you wish. You did, that's not it. You said so. Okay, did everybody get one? Okay, here's what I'd like to do. Does anybody have a birthday bonus? Let's take care of that first, so that when you're done, you can come up and turn your paper in. Does anybody have a birthday bonus they want to use today?
My birthday's on Saturday.
This coming Saturday? Well, happy birthday. Let's use yours today then.
Okay.
Question?
3 times 3.
3 times 3. Up by your name with a circle around it. Make sure your name's on your paper. Then when you are finished, you've done the 3 problems. I don't know what's on the back of your paper. It doesn't matter. There are only the 3 problems on the front. Bring it up, put it in the plate, and then you may work on something productively until everyone finishes. Take your time.